In this video, we'll discuss how to calculate the percent composition of a compound. To start off with, you need to understand what a mole ratio is, and that is simply the ratio of moles of each element in a compound. And if you look at the formula, it's very simple. So in this compound, we have 1 carbon, 2 oxygens. Now the way to look at that is there is 1 mole of carbon for every 2 moles of oxygen. So we would call that mole ratio a 1:2 ratio of carbon to oxygen. You can use that to solve mole ratio problems. For example, determine the number of moles of hydrogen in CH3CO2H if there are 16.9 moles of carbon. Step 1. Set up a proportion, and this is the proportion of moles to atoms. You want to put the unknown element on top, and since we're looking for hydrogen, that is the unknown. So there are unknown number of moles of hydrogen and 16.9 moles of carbon. We know that there are 3 plus 1, 4 atoms of hydrogen, 1 plus 1, 2 atoms of carbon. And then you just simply solve for the unknown. So 4 times 16.9 divided by 2 gives you 33.8 moles. You can also use the mole ratio to determine the formula of a compound. You need to know at least the number of moles in the mole ratio of one element, and then the actual number of moles. So we know the number of atoms, and now we know the number of moles for both, and we use that information. Step 1, set up a proportion with the unknown element on top. It's exactly what we did before, but now, instead of unknown number of moles on top, we have unknown number of atoms. So we are looking for H. We know N. So there are 3 nitrogen atoms, 2.4 moles of hydrogen, 1.45 moles of nitrogen. And then again, you're just going to solve for the unknown. So 3 times 2.4 divided by 1.45 will give you 5, and you plug that into the formula, N3H5. Now percent composition, this is a little different because we're looking at the mass. We're looking at the mass percent. So it's called percent composition, but it's also called mass percent. So if we're going to calculate the percent composition of calcium chloride, we have to divide the molar mass of each element. So there's calcium, and then there's chlorine. So divide the molar mass of each element. Notice chlorine, there are 2 chlorines, so we double that. We're going to divide that by the molar mass of the compound. And so if you calculate the molar mass of calcium chloride, it'll be 110.984. And then multiply that by 100. And so for calcium, molar mass of calcium divided by the molar mass of the compound times 100 gives you 36%. Chlorine, since there are 2, we have to double that. So 70.906 divided by 110.984 times 100 gives you 63%, 63.889%. So the percent of calcium is 36.111. The percent of chlorine is 63.889.